All right, so there's a lot of questions about the mean average deviation, and I'm just going to go through an example so it's familiar to you. So what they have is they have like three numbers. I'm just going to make up a couple. So it's like 4, 7, and 13. So that's going to be our population. So whatever the units are, who knows? But we're going to find basically the MAD of a sample of size 2. I'm not going to do all samples of size 2. I'm just going to show you guys a couple, and you can have a look. So if I want to do like 4 and 4, maybe 4 and 7, 4 and 13, and you can also do like 7 and 4, 7 and 7, 7 and 13, and then the other samples would be what would they be? They would be, well, I guess it doesn't matter, but you can actually see all the samples, and they show you how to do that. So it's all possible combinations of 2. So if I'm going to find the mean deviation, basically the way I have it in the computer, we're gonna pop it here. So the mean average deviation is equal to the sum of the absolute value of x minus x bar all over n. So what we're going to do is we're going to have to find x bar first, and then we're going to figure out the difference each one of these things are from x bar. So like the 4 and 4 is kind of easy because you can find x bar quickly. So x bar for that 4, 4 is 4 plus 4 divided by 2, which is going to be equal to 4. And then when you want to calculate all the x minus x bars, well, this is so our MAD, mean average deviation, is going to be equal to the absolute value of x, which is 4, minus x bar, which is also 4. So this is 4 minus 4. So this one right here is this x value, is this one. And this one right here is this average, because remember, it's x minus x bar. And then divided by, oh, sorry, I have to do the other as well. So I also have this 4 minus, the mean 4, and it's going to be all over 2. So the absolute value, it just makes everything positive. So if it's a negative number, it makes it positive. If it's a positive number, it keeps it positive. So really, it's essentially it's distance away is really what you're finding. So both of those are going to be 0. So this is going to be the absolute value of 0 plus the absolute value of 0 all over. Oh, that should have been a 2. That should have been a 2 because there's 2 of these. All over 2, and then the absolute value of 0 is 0, and same thing here. So this is 0 over 2, which is going to be equal to 0. So that's 0. Let's do one that's a little more interesting, like 4 and 7. So I have to find the mean again. So the mean of 4 and 7 is going to be equal to 4 plus 7 divided by 2. So 11 divided by 2 is going to be some number. So you're welcome to actually plug all this stuff in your calculator at one time, but I almost would rather just like kind of write them out because it gets messy if you try to do that. So 11 halves is going to be 5.5. So now I'm going to figure out the mean average deviation of this 4 and 7. Well, it's going to be the absolute value of this 4 minus the mean, which is 5.5, plus the absolute value of this 7 minus the mean, which is 5.5, all divided by 2. Then just use a calculator. So this is going to be 1.5. It's technically when you calculate that difference, it's negative 1.5, but when you take its absolute value, it turns into positive 1.5. Same thing here. This is going to be 1.5 as well. So plus 1.5, all divided by 2 is going to be equal to 1.5. So what's kind of neat is they say on average how far away are these numbers from their middle, from their mean. So really what we're doing is it's another way of calculating spread. Like standard deviation is a way to kind of calculate the spread, so is this as well. And what it's meant to do is just kind of get you guys good at formulas. So we can keep calculating all these things, but now you know how that's done. I'd have to find the mean of 4 and 13. That would be a particular number, and then I'd have to do this as well. Now, so after you're done filling out that list, they ask you to take the mean of these numbers. So you're going to have to add all those numbers and divide by how many there are. So divide by how many? Like 1, 2, 3, 4, 5, 6 right now, but we know that there's a couple more. So divided by how many there are. And they want you to look at this number and see how it compares to the mean average deviation of these three numbers. So what I'm going to do is I'm going to find the mean average deviation of these three numbers, and then we can kind of talk about what happens here after that. So in order to find the mean average deviation, I'm going to have to take their, I'm going to have to take their mean. So 4 plus 7 plus 13 all divided by 3. It's just 3 of the numbers. Divided by 3, so 24 divided by 3, that's nice, so it's 8. That's a finally a good number. Okay, so that means the mean average deviation for these things is, this is going to be your mean, so you're going to have to take each of your x's, so 4 minus 8, because it's the difference that is from 8, plus I'm going to have 7 minus 8, plus the absolute value of 13 minus 8, and then it's all going to be divided by 3. So let's see what we have here. So this is going to be, that's -4, but the absolute value of -4 is going to be +4. It's going to be -1, but the absolute value of -1 is going to be +1. This is 2 plus 3, so this is going to be +5. So this is going to be, 10 over 3. So I get about 3.3 repeating, so I'm going to go here. What we know is we round 1 decimal past the given data, and since our values were whole numbers, we're in the ones place, we're going to go 1 decimal beyond that, so we're going to go to the tens place. If these had if this was like 4.1, we go to the hundreds place. You have to go 1 decimal past the given data. Okay, so now that we know that the mean average deviation is 3.3, that's basically how far away they kind of deviate from their middle. You're going to take this number and compare it to this number, and what you'll notice is the number's not going to be the same. The reason why they're not the same, or the reason why they're asking the question, is they're asking if this is a biased or an unbiased estimator. So it's going to be a biased estimator because these numbers differ. If they were the same, they would be considered an unbiased estimator. And we actually have a complete chapter talking about that, so we're going to go into that a lot further, and you guys will see more examples of me setting up a table and actually asking if it's a biased or unbiased estimator. That's about it. If you have more questions, feel free to keep asking. I can make more videos. This helps.